My name is Junhe, a senior student majored in chemical engineering. I participated in the summer undergraduate research in engineering program, the SURE program, at the University of Michigan, working in Dr. Timothy Scott's lab, the Polymer Dojo. I also worked with an undergraduate student, Guo Kang, and a PhD advisor, Tao. I recommend the SURE program for students in College of Engineering who are willing to applying for a grad school. I learned a lot this summer as a full-time lab assistant about how to come out and research idea and then use experiments to prove whether the idea is reasonable or not. The goal of my research is to find out some special type of polymers with desired functions that can be synthesized repeatedly and quickly. Those polymers have information stored inside due to the arrangement of the series of building blocks when they are being synthesized. What I studied this summer is called peptoids. Peptoids cannot be found in natural world, but it's quite similar to a nature existing polymer peptides, which is significant to all creatures on the earth. Due to the similar structure, peptoids are able to play as information carrier. Also, it is more stable in different pH conditions and more resistant with denaturants including metal ions. To start the synthesizing, I use a kind of resin which can be obtained commercially. It has an amine group protected. I can start my reaction after the protection with corresponding reagents. Amine reacts with bromoacetic acid and the carboxylic acid can be attached on a single second amine with any kind of substitutional group. Thus, I am able to build up a chain by adding a bromoacetic acid, then a second amine, bromoacetic acid, a second amine, and so on. After that, I cap the chain with acetic acid and cleave off the resin eventually. After the reaction, I purify the product with a lyophilizer by vacuum sublimation. A mass spec can detect molecules based on different molecular weight. I run the mass spec after the reaction to check if a desired product can be observed in the mass spec. For example, I used to synthesize a peptoid with a molecular weight about 809. In the mass spec, a peak on 810 corresponds to the molecule with 1 unit of proton, and the peak on 832 corresponds to the molecule with 1 unit of sodium ion. There are some other peaks on the mass specs that is not comes from the product. Since there are still junks in the final products, the reaction can be improved. First, I can do some purification steps such as HPLC or GPC. Also, I may change reactants to stop the generation of byproducts. Also, I'm trying to reduce the reaction time by changing the reactants.